Merritt attended the University at Buffalo in civil engineering. After college, he worked for a contractor in upstate New York running bridge and highway construction projects and ran his first polymer concrete bridge deck overlay project in 2002. He joined Kwik Polymers in 2006 as the Northeast Regional Manager, has provided design and technical support for projects of all sizes using polymer materials for bridge preservation, is currently in charge of sales for Kwik. He's a member of the TRBHD 40 Committee on Polymer Concretes, Adhesives, and Sealers. So please welcome them.
Yeah, so Merritt and I are going to kind of tag team this, and so we haven't got the choreography all exactly worked out, but we think we can get through it pretty well. So you heard the introductions, and we wanted to talk a little bit today about polyester polymer overlays in North Carolina. We've just begun using that, and we're going to go over generalities about polyester polymer and a little bit more specifically about our first project that we used this on. So our first project was, well, a little background. We, I guess Dan had met Merritt a couple of years ago at a conference, and we had some interest in that, and so we kind of vetted the product a little bit, contacted some other states that had used this before. I got in touch with Dick Dunn, and he got me in touch with some folks with New Jersey, and we talked to several states around and tried to figure out, you know, the benefits and the problems with using this material, and we came upon this project right here. It's an interstate maintenance project in Cumberland and Harnett County, and in that project there's actually 5 bridges. 3 of the bridges are getting latex modified overlays, so they're getting hydro demoed and then latex modified. And then we're also doing the PPC on 2 of the projects in Harnett County. And we felt like it was a good opportunity to use PPC because we could do sort of a side-by-side comparison to see how things worked, to see how well things went. And one of the great things about this project in particular, where we chose to do the PPC, at this interstate, it's on I-95 at the intersection of US 421. And there is a project about 8 or 10 years from now to redo this whole interchange, in which would replace the bridges. So we knew if it didn't work out very well, we only had about 8 or 10 years we had to deal with it anyway. So
thanks for the confidence.
yes. So anyway, that's kind of how, you know, this project, the specifics on the bridge just kind of lent themselves to trying the polyester polymer concrete, or the PPC. Just a few things on about the project you can see there. You can see the location is on I-95 there. It's about a third of the way down the state on I-95. This particular area does not get a lot of salt and brine treatment. It gets a little bit, but not that much. Really farther west from there, north and west, gets more. And so we weren't too concerned about a lot of chloride infiltration on the deck, even though it did have an asphalt wearing surface. Here's a picture of the dual structures. Nothing special, nothing crazy or outlandish about these bridges. These are just kind of workhorse bridges. I think they're 4-span bridges. I think maybe about 200 feet long. Again, nothing special about them, nothing unusual. Again, as I talked about, we like this idea because it had sort of a side-by-side comparison about what we could do on these bridges. Between the LMC and the PPC. The LMC, again, called for scarification and hydro demolition. That's what we typically do in North Carolina for our latex modified projects. The PPC called for milling and then the usual shot blasting to prepare the surface. I'll let Merritt talk a little bit.
Thanks.
What PPC is it's made up like a regular concrete, only what you've got is instead of rock and sand and cement, you have rock and sand and plastic, but it's still mixed similarly to concrete and placed similarly to concrete. Some additional features are that it has a high molecular weight methacrylate primer coat that goes down before the overlay material, What this means is that it has a integral bond with the substrate, so it's a liquid chemical primer that saturates the top surface of that concrete, then reacts with the overlay, so that basically the overlay is acting as a composite with the deck, cannot be removed without getting into the concrete. So in order to stay put for the life of the overlay, that's a big key to the success. No cement or water, so we're off to some more non-traditional materials, but that gives us other features. Typical 1-inch thickness, which we were very close to on this job. Caltrans, California Department of Transportation, developed this material. With some industry partnerships, they came up with this material. They started researching it actually in the late 60s, but really finalized their design in 1983. And the design has not changed since. Some of the properties, this is what we get from using plastic instead of cement. We have impermeable to moisture and chlorides. It's zero permeability. So we're all talking about brine and rock salt, that kind of thing. They just don't get through it. They just sit on top of it. It's made of plastic. Wise man in the front row once referred to the brine that we put on bridges as liquid bridge remover. And it stuck. It stuck to me. And I think the name of the game is keeping that out. And I think, or at least not letting it take effect. You've got epoxy rebar here. You've got different types of concretes. Our version of it is to put something on the top that does not let that into the bridge deck. The primer bleeding in gives you that integrated chemical bond. That means it can't be removed. That means it actually stays with the bridge for the life of the overlay. Very strong, high wear resistance, so you have good friction for the life of the overlay. That never drops. Other feature that tends to get us a lot of our work is that we return traffic 2 hours after placement. So not just rapid cure time, but very fast. So all of our work happens majority of our work happens at night, very quickly, very fast traffic return. Why would they do this? Truthfully, and you see it kind of down in the bottom there, hydrodemo and latex is successful. They've had great track record with it in North Carolina. But so does this. PPC has a strong track record in other states, tends to be popular, seem to be worth trying. I think the other thing is that rapid 2-hour traffic return. So all the work can happen at night without any disruption to daytime traffic. Why else would you do it? You've got a deck that's worth preserving. Many decks are. Some decks are too far gone, but many decks are worth preserving. This gives you a way to rehabilitate and preserve that deck so that you get the life out of it that you want. Often decks that are in at least fair to good condition, 5 or above, can be treated with PPC and get another 30 plus years out of them. You can also use that material to patch the deck, which allows you to use one material with similar properties to the overlay on the project to rehabilitate the deck, which means fewer different materials within it, fewer different properties. You have those interfaces of different properties, those always lead to problems. So this is one material, one set of properties right up through. And a successful track record. I think they deserve to have another tool in the toolbox. Wanted to try this. So I circled it. Why not? To be honest, there's not things don't work everywhere. Everything has its faults. If a deck is too deteriorated, if it's too far gone for anything, this isn't going to work. That's the fact. If a deck needs to be replaced, you should replace it. My mantra, my big recommendation for everything, understand your problems and fix them. So, the Band-Aid for a shotgun wound, that kind of a thing. Don't try and do something that is rehabilitation or preservation when you need replacement. Let's not fool around with that. The other side to it is don't do too much. Maybe this fits in somewhere in between. They're doing hydrodemolition and latex modified concrete. Look at the second bullet there. If the majority of the top is bad and the underside is good, you've got a golden opportunity for hydro and latex, and it's going to be successful. It's going to work. That's not a time to use this. We may have something to offer for that, but we're probably not going to be economical. So understand your problems and fix them. Don't do more and don't do less. Don't put sealer on a deck that needs an overlay, and don't put an overlay on a deck that needs to be replaced. This is another tool for the toolbox. I think North Carolina came out with a good understanding of where this fits, and will continue that understanding. Why not use PPC? You can't do it in wet conditions.
So yeah, just a little more background on the specifics on these two bridges that we chose. You can see the total area between the two bridges, about 13,000 square feet. Both of these bridges built in 1955, so they've been around for 60 plus years. The decks are in pretty good shape. NBI rating of 5, not super great, but not awful, of course. They had asphalt wearing surface on the bridge at the time we were starting the project. We ended up milling all that off and coming back with 1.25 inches of the PPC overlay. That's just a typical section of the bridge there. 28-foot clear width, 4 girder system there.
This is milling off the existing overlay. Everybody should be able to recognize that. The idea is to get to the concrete substrate, get all the asphalt off, get all the membrane off. You need all that removed. We need concrete substrate. Other side of the idea is you don't want to remove too much of that concrete. So it's kind of a balancing act. It's frankly a little bit tricky, but people who are used to milling are usually pretty good at it. Milled surface before being cleaned, all of it should look pretty typical to many of us. Next thing to do, identify unsound areas. So train drag, hammer sound, this is all the stuff that we're used to. One of the big ideas here is, as this compares to the bridges that they're going to do on the other part of the project, only remove the bad concrete, don't go beyond that. So we're not removing any, besides the milling off of the asphalt, we're not removing any prescribed section of the top of the deck. We're just taking out the asphalt, and then you sound it to remove the bad. We're not exposing the rebar. We're not taking out any good concrete. As long as it's good concrete, it can stay in place. Sound it, find the bad, take it out. Patching. Looks a lot like other patching, but now it's with PPC as the patching material. Shot blasting the surface. What this does, after milling, this is basically like a heavy sandblast, but it uses steel shot. It vacuums itself up and then can be followed up with a magnet to get any steel shot that's left, and also then you blow it off with a compressor. But the start to this, part of it that's really great is it's almost like a very aggressive sandblast, very uniform in its approach on the surface, does a nice wide area of clean. And because it vacuums itself up, it actually pulls in the shot blast dust, which is what it's removing, and pulls it into a hopper and can be dumped off-site. So you don't make a huge mess out of things. It's very efficient too. Primer, I mentioned that methacrylate primer. Really high-tech installation methods. The guy rolls it on with a paint roller after dumping it out of a bucket. What it's ending up doing, though, is that it's filling the pores in the top of that concrete, saturating it. Cracks, small cracks, big cracks, any cracks, it's going to fill those in by gravity feed because you're pushing that puddle around. You're pushing this excess liquid around. It's going to fill those cracks, it's going to bleed into that top surface of the concrete, saturate it, then react with the overlay. This is a blend of super high-tech and not so high-tech. Notice they've got a slip-form paver, putting the material down. In front of that is a mobile mixer truck making the material. Behind the paver is a guy with a float in his hand, guy with a Fresno. It's not, it's a blend of high-tech and not so high-tech. Back to the features, open to traffic in the morning. Commuters, daytime traffic never knew that this work was going on. They just knew that one day it rode really bad, the next day it rode really well. No daytime traffic disruption. And here's what it looks like in the end with traffic on it. Looks back like a bridge again. They opted to saw cut groove this particular installation. You can also tine it. This one they opted to saw cut groove it. Quieter ride, more uniform ride. Still water dispersion and good friction. Should look familiar. Still looks like a bridge deck.
We thought we'd put together a little cost information here that was associated with the project, again, the LMC work, as well as the PPC work. You can go down the list. We went through each one of the bid items associated with each part of the work, and you can go through there from the scarifying to the hydro demo, down to grooving the bridge floor. And You can see about $37, $38 a square foot for the LMC and hydro demo, which is about right for our state. Our range is probably somewhere in the neighborhood of $35 to $40 a square foot. It varies depending on the conditions and what's going on, but that number is about right for us. And then here's the items we looked at for the PPC overlay, the milling, the deck, any deck repairs that were associated there, down to the grooving. And that's about $26 a square foot. That's a little bit higher than what I think the typical cost is for most places, but you know, this was our first project that we had done, that we have done. We have since let a couple more projects with PPC. I know the project, I think on one of the more recent ones, it's about $24 a square foot. And we expect as we do more and more work with the PPC, the cost will continue to drop for us. Overall, the project was very much a success with the PPC. Again, the quick turnaround was a great help for us. It's a little bit, obviously 30% cheaper than LMC. Really, probably the biggest difference there is the hydro demo cost. And again, as I said, our cost for the PPC was a little bit higher than typical, but we expect it to come down as we do more and more of these PPC overlays. You know, we're going to continue to monitor this PPC. The division engineer for this area drives across these bridges almost every day, so we're going to make sure that they are in good shape and this is working. Again, we've had several more projects that we've let, and the prices have been coming down on those. As Merritt said, this is just another tool in our toolbox. We're not getting rid of LMC. We're not getting rid of epoxy overlays either. I mean, just as a test of how good LMC can be, on the three other bridges on this project, on two of those bridges, we're doing an LMC overlay on those bridges. They were overlaid with LMC in 1984, and they've held up for obviously 33 years. So, you know, again, we're not getting rid of LMC. One of the nice things again about the PPC, Merritt showed that on this job we used I guess a paving machine to place this material. On some of these smaller projects, really on this project, it could have been done with a screed, with more of your typical concrete placement methods. So we think that is going to be a help for some of our smaller contractors as we move forward, do more and more of this type of work. So we're learning, we're figuring out what is the best projects, the best places to use the PPC. Any questions?
Hi, Tim.
Yes.
Great presentation. One quick question I have is, when you have the cold joint between the two layers, how does that work in terms of, you know, when you're putting different lanes or whatnot?
Oh, so the joint between the two, say the two pulls of the PPC.
Right.
Right. I'm gonna let Merritt talk to that.
It sticks to itself like crazy.
Okay. So there's no line or anything. The other question
No issue.
The other question I have is, what's the depth to which this is economical compared to rigid overlays? Are you talking maximum 1.75, or you can go deeper?
No, we've seen, I think the thickest I've placed it in one placement was 18 inches. Thanks New Jersey. The thickest I've seen it with a slip-form paver was probably between 8 and 12 inches. We do grade correction, settled approach slabs, that kind of thing. Obviously, you wouldn't place it that thick on a bridge deck. Where the economy crosses over, you know, for me, I feel like it's not the thickness itself, it's the removal. And if you really want to get into the top mat, then you're into hydro demo, then latex makes perfect sense. And so I think it's more the direction that you're going with it, where you cross over. With ours, the thickest average that we see on a bridge deck is usually 1.5 inches, 2 inches to replace a concrete overlay down to its original bond line without hydro demolition. Where the numbers fall really is an individual thing. But does that cover it at all?
Thank you.
Good.
Jeff's question was if you had a deck that didn't have the asphalt wearing surface on it and you wanted the PPC on there, would you do a milling? Yeah, we have done that. That's a situation where we don't have to worry about a grade change situation. And so, you know, typically on the other projects we've done, we've milled an inch and come back with an inch of the PPC. And, you know, of course, that could vary as whatever you need to do, so.
And you can look at your chloride contents. If you, like the state of New York does a lot of their work, they mill an inch and place an inch. And not to air their dirty laundry, but they don't even really do chloride content tests on a lot of them. They just figure that that's a good strategy to get the worst of it out of there. But if you wanted, you could look into chloride contents and that kind of thing. The majority of our overlays nationally are just shot blast and overlay. 80-something% probably are just shot blasted. It's these other cases where you've got grade issues to take something out or chloride content. Designer's option.
Thank you.
Does the PPC act compositely with the concrete deck such that you can account for the thickness in calculating capacity?
You sure could, nobody does.
People often think, you could, it does act as a composite. We can give you the properties of it and everything. We've got all the mechanical testing that we could give you. The fact is, most designers don't take that into account from what I've seen. It doesn't add that much because of the thickness and just the properties of it. Usually people take into account a little bit of analysis if they're replacing a thicker section of concrete. Then you want to go to that. As far as a structural benefit, it's rarely taken into account.
Right.